Section 5.3 is where we are going to prove triangles are congruent still, but now we've got some shortcuts. So the first one we're going to use is side, side, side. So if you have three sides of one triangle that are congruent to three sides of a second triangle, we know the triangles are congruent. That's our shortcut we can use instead of proving all corresponding parts are congruent like we had to in the last section. So on this first example, they're going to give us some information, and we're going to have to prove the two triangles are congruent. We are not going to use the flow chart that you see below there, so we're going to make our own T-chart proof. So go ahead and make your T-chart, and then you're going to want to copy all that given information over there in that first row. So then my next step is I want to make sure all of the stuff they gave me is marked in my picture. So QR is congruent to SR. I went ahead and marked that with one tick mark. Then it said that RT is bisecting QS. That originally was not marked. And so therefore, if it's bisecting, I know it's cutting it in half. And so these two halves are equal in length. So since I am marking that in my picture, it now needs to be said in my proof. So that is why I am writing QT is congruent to TS, and that was because we used the definition of that bisector. Now I've taken care of everything for my given, and I want to see, is there anything else congruent in my picture that's not already marked? Well, look again from what we did in the previous section. Notice this side here is shared on both triangles. So would it be congruent to itself? Absolutely. So this is my third side that's congruent. And remember, the property that says I'm congruent to myself is reflexive. So I would write RT is congruent to RT by the reflexive property. And again, that's a piece of information that will be used a lot in the next couple of sections. Now I see that I've got three sides congruent to three sides of my second triangle, so I know my triangles have to be congruent by my shortcut side, side, side. Okay, on the next piece, example 2, we are not going to figure out if these triangles are congruent on a coordinate plane, so we're going to skip that part, and we're going to go over here to the next part. And we're going to prove if these triangles are congruent again, but now we get to use side, angle, side. So if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the triangles are congruent. So for example, when you have two sides congruent to two other sides in a triangle, the included angle is the angle that is formed by two adjacent sides of the triangle. So that means that it would be this angle would be in between my two sides that are marked. Same with over here. That would be my included angle. So that is what it's referencing when it says that vocabulary. So in example number 3, it has a lot of words, and it gives me a playground equipment, and it's going to ask me to prove that those triangles are congruent. So the first thing that I did was I had to find where my triangles are because the picture was kind of hard. So your two triangles that you're focused on are these two here. This guy is labeled J and L, and then I have K and M. Okay, so I'm going to read. The playground equipment shown appears to be made of congruent triangles. KL is congruent to LM, and angle JLK is congruent to JLM. Write a two-column proof that proves these two triangles are congruent. So I started with my two-column proof, which they've already started for me. They said the first statement, KL is congruent to LM. That was true because it was given. Then the next piece they put was angle JLK is congruent to angle JLM, and that also was given. Then that takes care of everything they gave me. I then have to find something else in my picture that's congruent that's not already marked. Again, I see this side that both triangles share. So that means it would have to be congruent in length because it's the same side, but just used on both triangles. So I would write JL is congruent to JL, and that again is because of the reflexive property. I'm congruent to myself. Now I notice I've got 3 pieces, and I'm going to see if my shortcut works, and it sure does. I have 2 sides and the included angle congruent. So therefore my triangles are congruent by side angle side. Pause the video and try the check question. So in the check question, I highlighted my 2 triangles so I could see them better. And then I saw that DE was congruent to FE, so that was part of their given. And then I saw that also they tell me that EG is bisecting that angle, and that is also given. This part is not drawn in my picture, that EG bisects DEF. So therefore, I would want to know what that's telling me. So if EG is bisecting this angle, that means it's cutting it in half and it's splitting it into 2 equal parts. So therefore, this angle, DEG, is congruent to this angle, FEG, because of the definition of angle bisector. I only have 2 things marked on each triangle, and I need a third in order to use one of my shortcuts. So one more time, I see this side in between here being shared on both triangles. So therefore, EG is congruent to EG based off the reflexive property. And now I have 3 parts in each triangle, so that's why I can say they're congruent by side angle side. Now, just again to reiterate, make sure that when you have side angle side, you are using the angle included. So it has to be the angle that uses the 2 sides that are marked congruent. Okay? All right, that is it for side, 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 and side angle side.